Apo.
Okay, so good morning, class. So today we're going to discuss the ice refrigeration or refrigeration of applied to some fruits. No, in this case, apples. No. So first we have to read the problem and then analyze, then jot down all the given, and then start to solve the problem. No. So the problem states 1,000 kilogram of apples will be chilled from 27 degrees centigrade to 5 degrees using ice. Will 100 kilogram of ice at 2 degrees centigrade be enough to cool down the apples? Exactly how much ice is needed to cool the apples? So first, in analyzing the problem, we have to be systematic. Systematic means we have to jot down first all the given data or the known data, those data that are known to us. No? So I'll be using the space provided here in the PowerPoint presentation so that we're not going to flip uh, side the sides or turning back and forth on the page. So first, what is the first given? The first that was made known to us is the 1,000 kilogram of apples. What is that? So we could call that as what? Mass of apple.
Apo.
Yeah. So 1,000 kilogram. Okay. And those apples will be chilled from 27 degrees centigrade to 5 degrees. So we could say that this is temperature um, initial or final. For example, final is of apple is 5 degrees centigrade, and the temperature initial of the apple uh, when it is made available now before cooling, before chilling, is 27 degrees centigrade. So these are the known data or the given. So given or known data, meaning it's provided in the problem. Now, the next statement says, will 100 kilogram of ice at 2 degrees centigrade be enough to cool down the apples? Exactly how much ice is needed to cool down the apples? So my question, class, is 100 kilogram part of the given or not? Is it given? Can we use that?
Mm,
Can we use that in the calculation?
di na po.
Yes or no?
Di na. No.
No. Why? Actually,
Pang-analyze.
correct. So the question was about 100 kilogram. Of course, it is given as a question. So here, it's not part of the data that is going to be included in the calculation. Actually, the 100 kilogram, sorry, I'm not used still. I'm not used to writing in digital pad. So the what was that 100 kilogram here is not part of the data that will be included in the calculation. Rather, it's part of the so-called test question or evaluation question. No, evaluation uh, question. Meaning, after after you have calculated the amount of ice needed to cool down the 1,000 kilogram of apples from 27 degrees centigrade as an initial temperature to 5 degrees centigrade as the final temperature, is it enough? No, if you are using 100 kilogram, is it enough or not? So you can our approach here is we can calculate the right amount of mass, no, or the quantity of ice to be used in the cooling process from 27 degrees centigrade to 5 degrees centigrade, no, with 1000 kilogram of apples. Then we are going to compare with 100 kilogram if it's more than or less than, no, so that we can test if 100 kilogram is sufficient or not. So that's the problem is all about. It's really important to understand the problem very well before we go on to the solution. So let me go to the next page. So as what we're writing, we can jot down all the necessary information that is available and all the information that we can get from standard references. Okay. So my question, my next discussion is this. No. Um, Let us verify all the given. What is negative 2 degrees centigrade, class? What is this? What is this?
Initial temp.
So
Initial
temperature, oh
temp.
yeah, yeah, initial temperature of ice. Initial temperature of ice. Now, I might use this space as annotation, no? Space for annotation, so that it will be all uh, more clear to us. Initial temperature of ice, meaning that is the ice available to us, no? The ice, we have negative 2 degrees centigrade. Now, is this given in the problem or not?
No.
No, it's not
No.
given in the statement of the problem, but it is necessary in the calculation because it's standard. I mean, everybody knows that the freezing point of ice is what? When the water
Zero.
starts at 0 degrees centigrade, something is happening. Something will happen. The 0 degrees centigrade water will become 0 degrees centigrade ice. You cannot measure the temperature because there's no change in temperature. How can you measure the temperature? No, there's no sensible heat. We have learned that now many times. I was stressing because in refrigeration and air conditioning and HVAC, the concept of sensible heating and latent heat is very important. What's happening here is this, no, 0 degrees centigrade water, it will become 0 degrees centigrade what? Ice.
Nice.
So both of them have exactly the same temperature. And when you measure the temperature, you cannot get any difference, no? Is there any delta T here? Delta T is present or not?
Zero.
Zero, no? Zero minus zero, no? If there's no change in temperature, there is no heat transfer, correct? Because there's no
Mm.
temperature change. So how can you measure the delta or the change? Meaning it's constant, no? 0 to 0 is constant, meaning it's not changing. So when it's not changing, the temperature, there is no sensible heat. No, because sensible heat involves delta T, right? There's a change in temperature, something you can measure, something you can feel. But here, there's no change in temperature, there's no heat transfer. No, there's no mode of heat transfer. That's why zero. Heat transfer is zero. But there is something happening, and that is what? What change is happening here?
Latent heat.
I mean, what change?
Change.
Change
Change.
of
State. Change state.
phase or state. In Tagalog, yung form, no? Anyo. No? Yung tubig, yung tubig, yung tubig naging yelo. no, or vice versa, yung yelo naging tubig, no? So there's no change in temperature, but rather there's a change in phase, right? So it is not, again, no, it's not given in the problem. Nobody will give you but yourself. So you have to look for references. Yeah, it's commonly known like density, no, or acceleration due to gravity. No, they will not give you those constant in the problem, but they assume because you are an engineering student, you should know by now those are necessary constants that will be used in the calculation. Now, we go to the next, and that is TF of water. What is this? TF. TF means
Final temperature.
temperature final of water, meaning that is our target. No, my question is, have we have we reached the freezing point of water here in this case? Yes or no? Na-reach na ba natin yung temperature, yung freezing ng water here? Hindi.
Yes.
Naging yellow ba to sa 5? Hindi. Hindi, di ba? Kasi
Dati no, hindi.
ang yellow ay 0 degree centigrade. So ibig sabihin, yung yellow, ang final temperature lang na nagmamatter sa yellow ay 5. At yun din ang temperature na final ng ano, apples, right? Naintindihan ba yung problem? O, punta tayo dito para maintindihan. This side here is side ng ano, ng ice, no, at saka tubig, no? Ang side naman na to, no, ang side naman na to, mostly, except for this, no, dapat nandito yan, ay tungkol sa mansana. So this side on the right is talking about the the information about apple. Apple. I'll be using another color, no? So that we can differentiate. What are the data? Based on the problem, what are the data available to us as far as apples are concerned? So we have an initial temperature of apples. First, I would like to discuss the quantity of apples. How many apples do we need to cool down? To cool, I mean, to refrigerate. 1,000 kilogram. Okay. So 1,000 kilogram. If we may state this in another term, 1 m ton. What is m ton?
Metric ton.
Metric ton, no? Because if you are using ton, as we have articulately explained last time, 1 ton was defined by US and England as what? 2,000 pounds. No. So if you convert this into kilogram, it is less than 1,000 kilogram now because it is called short ton. And what about this long? You have to understand this short, long ton. And if you are from Europe, they they're using the term ton, not ton. From France, no, from France. So what is ton here is the 1,000 kilogram. No, so if you convert this in pounds, how much? 2,204 pounds. No, so 2,404 pounds. This is 2,000 pounds. No, so you should be careful if you are using short ton or long ton. So another name for long ton is what? M ton or metric ton. No, because 204 is much, no, compared to 2,000 pounds, no? So 204 pounds, no, malaking bagay yan. It is a lot, no, in any computation or even, no, in business side, that is too much. Okay, So I would like to emphasize that the 1000 kilogram here, we can say that this is like metric ton. Okay. Now we go to the temperatures of the apples. 27 degrees centigrade here is the initial temperature of apple, meaning that's the available temperature of the apple when before cooling. Now, the target temperature of the apples to be chilled is 5. No, we don't have to make the apple in frozen state. No, actually, you can search in the internet. Now, what's the freezing point of apple? Now, what's the freezing point of beef? What is the freezing point of strawberry? But in this particular case, in this problem, we are not required to freeze. No, we are not required to freeze the apple. We only have to cool down the apple from 27 down to 5 degrees. Is it okay? Is it clear, class? Class.
Yes, sir.
Okay, the problem. Now, there's another term here that we have to emphasize, and that is L. What is L? L sub F. What is this? Latent what? Heat of fusion. No, so whenever you are seeing this LF, that is latent heat of fusion. No, so latent heat of fusion. Now we will discuss that now. So latent heat of fusion. When do we use this? Latent heat of fusion is used whenever the ice, like the ice, is changing its form from ice to water, like 0 degrees centigrade water. No, so there's no change in temperature, but there's a change in form, as we have discussed a while ago, or state. So when there is a change in state, no, that is the saturation point, because it can no longer hold, no, the body, or the substance can no longer hold the temperature, so that it should change into state, no, 0 degrees ice. Then it's not changing the temperature, but it's changing the phase. It will become 0 degrees water. So there's no involvement of delta T, or change in temperature, but there is a change in phase, and we call that as latent heat of fusion, meaning there's an energy being released during this process, and that is the latent heat. And we might consider that in the calculation. Okay. Now, I would like to illustrate, or to make some illustration, so that the situation is clear to us. No, I might be using pardon me, but I have to use the vacant space. No, so that we are not going to flip back and forth. Yeah. Now I have here lines, and I'll be designating this as 0 degrees centigrade. Now, as an origin. Of course, all of you are familiar with coordinates, right? Like this Cartesian plane, no? But this is refrigeration. I would like to use this as like a timeline, with the temperatures, no, as parameters. I have here 0 degrees centigrade. To the right, so that I can explain to you in a very simple manner. I want to use the right side as my condition with the what is our fruit? Apple. Okay. So on the right side of the xy axis, that means, actually I'm gonna be using only x axis here now, but let me just have this like this intersection so that it will be clear as like a boundary of the two. So on the right side is my condition about apples. On the left side, what I'm gonna write on this. This is my condition on the ice, or let us say water, right? Now the question is, what do we know about the apples? What is the initial condition, class?
27 degrees.
Yeah, I have an apple which is 27 degrees centigrade. Now, pardon me with my drawing, but just to help us, just to help us a bit. So I have here what is the weight quantity. So the problem states that there's a 1,000 kilogram of apple having 27 degrees centigrade initial temperature. What do I need to do with this apple? I'm gonna cool this apple up to my target. What is my target?
5 degrees
5.
Celsius.
Oh. So target. When I say target, that is my goal. That is the final temperature of the apple that we are considering. Is it clear, class? At this point, is it clear?
Yes, sir.
Maliwanag ba?
Yes, sir.
Sagot lang ha, para alam ko baka
Yes po, sir.
baka kasi tulog na kayo lahat eh, hindi ko pa alam. Ngayon,
Hindi po.
27 up to 5 degrees. Yan ang gagawin natin. That's what we're trying to do in this apple. Papalamigin natin. Papalamigin natin ang mga mansanas. Gagamitan natin ng yelo. Ngayon, ano ang mangyayari sa yelo? Bago nyo sagutin yan, ano ba ang initial temperature ng yelo? Gamitan natin ng ibang para makita.
Negative 2.
Saan ba yung class, sandali. Nasaan ba yung natin? Ito. Yan. So gamitan natin, we're gonna be using another color. What is that? Blue. So para maiba. For a change, we are done with the condition of the apple. Now we're going to you know to to explain the side of ice. The ice is needed to cool down the apple. So yeah. Here I have ice. No ice. Let me draw the block of ice. Block, because it's 1,000. What we're going to cool down is 1,000 kilograms. So it needs a lot. I mean, it needs a considerable amount of ice, right? Do you see in my drawing, class? What's color?
Yes, sir.
Yeah. So
Yes po, sir.
our,
Opo, sir.
our ice, the initial temperature of ice that will be used in this process is how much?
Negative 2. Negative 2 po.
Negative 2.
Celsius.
Yan, maliwanag ba yung illustration natin? We have to be very clear, no, in this thing, so that no, we understand what's happening. The ice, the apple. What is happening in these two things, no? The approach here is based on scientific principle. It's not based on guessing or feeling or whatever. It is based on science. What kind of science? The science of thermodynamics, right? And thermodynamics also, of course, it's related to heat transfer. Why? The root word for thermo, not thermometer, thermographic. What is thermo? It's It is heat, 'di ba? Thermos. 'Di ba pa nagluluto kayo ng kape, magkape ka na. Kuha ka ng tubig sa thermos. No? Ibig sabihin, may mainit na tubig doon. So, when we talk about thermo, it's about heat. What is dynamics, class?
Mm, moving or
Pag
sorry,
dynamics,
movement,
ay,
movement or
movement yun, no? Ibig sabihin, it's about movement, no? Kumikilos, hindi siya stagnant, right? Kung kayo ay kumukuha ng mechanics, para maintindihan ha, so that you will understand what we're talking about. What are the two branches, the main branches of mechanics? There are two, statics and
dynamics.
dynamic. So one is not moving. So we are talking about forces, balance, equilibrium, maybe some part of velocity. But here we are talking about velocity and acceleration. Here is more on forces and position, right? Mga angle, mga position, mga force going to the right and left. But when we talk about dynamics, it has to do with movement. And movement, the main factor of movement is what? Velocity. Okay? And when you change the velocity, when you get the rate of velocity, when you get the derivative of velocity, it will become acceleration. No? So I'm just discussing this because I want to emphasize the meaning of dynamics. So thermodynamics is transfer of heat, movement of heat, no? Most of the time it's mechanical, no? But even there's no mechanical or machine, heat can be transferred like that of the apple, no? Or others, no? What I'm saying is we should understand that there's a transfer of heat. Now, is there any transfer of heat involved in our problem? Where will the heat come from? Is it coming from ice or is it coming from apple?
Apple
From apple.
and
And
apple.
why? Why?
Greater temperature.
Oh, anong law yon? What's that law?
No,
Second law of
thermodynamics.
thermodynamics. So the first law is already consumed. I mean, it's already understood, no? The first law states law of conservation of mass or energy. Energy is not it cannot be created nor destroyed. It only just transfer from one form to the other, from one place to the other. In this case, the energy of apple should transfer to the ice, right? And it is complemented by the second law of thermodynamics, which states that the flow of heat always transfer from hotter body, mas mainit, papunta sa mas malamig. Hindi pwede na malamig pumunta sa init. Na parang yung init ng araw, tas may bahay ka. Yung init ng araw, the heat of the sun rays will pass through the wall, no? Ay yung bahay mo naman ay mas malamig. It's initially colder, no? It will pass through the wall. So heat transfer from hotter body or higher energy gradient to the colder energy gradient. No? So first and second law of thermodynamics applied here. No? So now what I would like to discuss is this, no? What is happening when the heat of the apple transfers to the ice? -2. What's the next?
Tataas.
If I place the apple, what will happen to -2?
Tataas.
Oh, you should be careful in, you know, our world, ang mundo natin ay punong-puno ng tinatawag na relativity. Alam niyo ba yung relativity, class? Yung relativity ay pahambing, di ba? Pag sinabi kong pahambing, uh, it's like a concept na mahirap ipaliwanag, depende, dapat i-quantify mo, no? I-quantify mo yung mga tinatawag na boundary condition o yung mga yung mga condition. No? Pag sinabi mong tataas, bababa, mahirap 'yan, no? Kasi lahat 'yan mga concept. Pag sinabi kong tataas, anong ibig mo sabihin sa tataas?
Tataas po ang temperature.
Pag tumaas ang temperature,
Iinit.
yun, iinit. Di ba? Ibig sabihin, going to be hotter. Kasi, pag yung mga tao naman, pag sinabing mataas, ang nakatutok sila sa numerical value, di ba? 2, 3, 4, pataas yun. Pero sa negative, hindi ganon, di ba? Sa negative, habang lumalapit ka sa zero, dun tumataas ang value mo. Di ba? Maliwanag ba? Tumataas ang temperature, ibig sabihin, negative, anong sunod? Negative 1, mas mainit. Anong sunod? Uh,
Zero.
maybe
One, two,
0.5
three.
muna, tapos 0. Tapos pataas, di ba? Pataas. Umiinit eh. Hotter. Okay, maliwanag ba? So, eto, bumababa ang value ng negative, negative 2, negative 1, pero tumataas yung init niya, di ba? Ngayon, pag sinabi mong tumataas ang lamig or mas lumalamig, ano ang maaasahan mo dito? Negative? Anong sunod dito? 3, negative 4, negative 5. Okay ba? Maliwanag ba sinasabi ang pinapaliwanag natin? Ngayon, pag tumataas ang number sa negative, lalong lumalamig. And ito yung tinatawag natin na temperature, ano, below, ano,
Freezing.
freezing. Oh. Mas mababa pa sa freezing dahil ang temperature na freezing ng tubig, which is a universal solvent, no, basihan ng lahat ay tubig, nagyelo siya ng zero. Ngayon, pababa ang temperature niya. Naging negative 5, naging negative 6. So, pababa ng pababa. So, temperature below freezing. Ngayon, ano naman yung temperature above freezing? Ito yung freezing, above niya is to the right. Nagiging 1, 2, 3, 4, no? Above freezing yun. Ngayon, ang nangyayari dito, class, gusto kong linawin. I want to be very clear on this. The temperature from negative 2, which is the initial temperature of the ice, will become what? Hotter. Hotter means negative 1, 0, 3, 4, 5. Saan siya hihinto? Saan dapat siya huminto? Yung yellow.
5.
Sa 5, no? Hindi siya pwedeng maging 6 or 7 kasi out of the question. I'll repeat. From negative 2, our heat transfer should only travel from negative 2 to 5. Maliwanag? Sa side yun ng ice. Ngayon, sa side naman ng apple, on the side of the apple, from 27, papuntang ano?
Five.
Papuntang 5, no? Hindi naman kailangang bumaba sa 5. Kasi 5 na nga yung ating target, di ba? Yung mansanas mo, gusto mo lang palamigin at i-maintain sa 5. Hindi naman sinabi ng problem na, palamigin mo yan ng 4, 3, 2, 1, at gusto ko mag-yellow yung apple. Walang ganong sinasabi. Wag niyo kayong magdagdag sa problema kasi marami na tayong problema sa buhay. Kung ano lang ang ipinapahanap, ng problem, yun na lang, no? Yun lang. Maliwanag ba? At this point, maliwanag ba, class? Kung anong nangyayari?
Yes, sir.
Okay. So
Yes
ngayon,
po, sir.
binigay na natin lahat. We were given all the information, we were given all the necessary data, including those data which are not found in the problem. I was saying this in the problem, this was not given, no? Temperature of ice. It's not given, but everybody knows what's the temperature of ice, no? Ngayon, ano pa yung mga kailangan nating malaman? Yung latent heat hindi binibigay, no? Pero dahil may na-involved na latent heat, we should know because we are engineering and we are engineers, we are engineering students. Some of the references are 335, no? 334. Okay lang yan, no? Baka ni round off lang or so. Wala namang issue yan. I'm more of the process rather than dung sa exact value, no? Ano pa ang pwede nating malaman na pwedeng gamitin dito? What are those information that we need in this problem that are not given in the problem statement? Yung sa pag-compute ng mga ganitong klase ng problema, hindi natin pwedeng ipagsantabi o baliwala yung mga data. Nasaan na ba itong ano ko? Yun. Yung tinatawag na ano yun, class? CP. Ano yung CP? Ano yung CP, class?
Specific.
Specific heat ng ng apple, 'di ba? Dapat alam mo yun. We should know the specific heat of apple. Nasaan yun? Ito pala sa taas ay no?
Given po, 3.6
Ayan.
po.
Hindi to given sa problem, di ba? Pero
Opo, pero
makikita mo sa references, no? So ang specific heat ng apple para isa lang, no, we might jot down here, no, so that we are just uniform in the value that we're going to be use 3.64 kilojoule per kilogram Kelvin, because every material, everything has a specific heat, no, whether meat, apple, material, plastic, gold, whatever. Okay, so ano pa ang kailangan natin? Nandyan ba yung specific heat ng tubig? Ayun, sa may bandang taas. We can see here, it's not given on the problem, but it is universally used because it's constant. Specific heat of water based on pressure is 4.186 kilojoule per kilogram or 4.187. No issue here. Another thing is specific heat ng ice. It's almost half of the specific heat of water, meaning specific heat is based on the material and specific heat is based on the temperature. For sure, there are specific temperatures na ginamit that are used so that nagamit nila yung ganitong value, no? Ngayon, pag yung tubig nalipat ng temperature, mag-iiba yan ng specific heat. Ito standard yan, no? Mga 15.6 yata or something, no? So there is a specific temperature for standard specific heat. Now, pag yung material ay nagbago ng temperature, magbabago yung specific heat niyan. Okay? Yun ang sinasabi ko dito. Now, pag maliwanag na to, if you believe that all these are very very clear, we go now to the solution, no? So we go now to the solution. We are going to make it like a one by one, no? So here, energy in is energy out. What is this principle? So this is equation, but based on principle. What kind of principle?
energy conservation,
Oh, energy conservation or first law
first
of
thermodynamics.
thermodynamics. Pardon me with my writing. I'm not yet used to writing in the digital pad, no? So meaning first law of thermodynamics states that the energy only transfer from one place, from one form to the other, meaning the energy of the apple, because there's an energy, heat is an energy, Q is heat, and that is energy. The heat of the apple will transfer to the ice, right? So ano mangyari sa ice? Tataas ang temperature, meaning from negative 2, no, magiging negative 1, umiinit, o negative 0.5, magiging 0, magiging 1, 2, 3, 4, anong last natin? 5, right? Tama ba? Maliwanag ba, class? Low?
Yes. Oh,
Yan.
Yes po, sir.
From negative 2, magiging ano siya, magiging 5, positive 5. No, yun ang mangyari sa ice, di ba? Ano naman ang mangyayari sa apple? Ulitin ko lang para malinaw kasi malap pag nag-exam tayo. Yung apple mula sa 27 degrees centigrade at ito ay ilan siya, ilan? 1,000 kilogram. The 1,000 kilogram apple from 27 degrees centigrade bababa. Now the temperature will be will lower down up to our target, which is 5 degrees centigrade. And this is simultaneously happening, no? Depende sa tinatawag na heat transfer rate, no? Nangyayari yan sabay. Pero but the thing I would like to emphasize is this, no? Both process should culminate, no? Should meet in this condition. The apple should reach the 5, no? And the ice here on the left side, the ice from negative 2 should reach the 5, no? Because ito yung target natin, di ba? Kasi yan ang nangyayari sabay. Okay? So now, we are clear with this. First law of thermodynamics, second law of thermodynamics, meaning the energy is coming from higher gradient, which in this case, between the two, the energy or the heat should be coming from apple. Sorry. Maggalaw. Okay? So ngayon, we go now to the solution. Very quick. No, napakadali lang nito. So Q ice equals Q ice plus Q water plus Q water. No, yung sa ice. Pag pinag-usapan natin yung ice, eto yon. This is what we're talking about, the water. But when we talk about apple, ano namang nangyayari sa apple natin? Eto naman, no? Yung sa apple ay eto, no? So this equation is about apple. Ano yung equation na to? Yung heat na i-release ng apple. Ito naman, class, ano tong equation na to? What is this equation all about? Ito yung heat naman na marireceive ng ice. Magalaw masyado tong digital pen. No? So, maliwanag ba, class? Is it clear? Class, maliwanag
Yes,
ba?
sir. Po.
Yes po, sir.
Ang heat ng apple ay marireceive ng ice. Kung anong nirelease ng apple, yun ang marireceive ng ice. Bakit napakahaba ng tungkol sa ice? Why is the equation of ice longer? So, MCP delta T is the general or mother equation, no? MCP delta T. A very, very general universal equation in terms of heat or energy or work or power, no? Let us check the unit first. Now, I would like to check the unit. Here, the unit is kilogram per second. Here is kilojoule per kilogram per Kelvin or degree centigrade, because whenever we're using absolute, like, ideal gas and other things, we should use Kelvin, no? Ideal gas. And delta T, of course, kung Kelvin na yan, kung centigrade to, halimbawa centigrade to, mag-add ka lang ng 273. And this whole thing will become Kelvin. So, maka-cancel yung Kelvin. Ano pa ang maka-cancel? What will be cancelled off? Kilogram. What will be left? Kilojoule per second, which is kilowatts, 'di ba? Ang kilowatts ay unit ng heat, 'di ba? 'Di ba pag sa mga problem 20 kilowatts at ganyan-ganyan, no? So, maliwanag na 'yon. Now, in this equation, we just would like to emphasize, here is the constant, meaning it's a common factor for all. Kaya nilabas natin. We take out the mass of ice. Ang tanong, is the mass of ice given? Or is that what we're trying to solve?
Unknown.
Unknown, no? So the mass of ice is the one we're trying to find out. We're trying to solve the mass of ice, right? Pero yung ice na tinatanong doon sa problem ay test question lang. No, it's a test question, is 100 kilogram enough or not? So that is the question, no? So ngayon, we'll continue. We have the CP of ice. What is this? 2.108. Delta T of ice we have, no? Temperature ng ice. Ano yung temperature ng ice na may involved dito, class? Ano? What is this temperature of ice na may involved?
New.
Zero, ay, negative.
Zero and negative.
Saan ba yun? Yun. Yung negative 2, di ba, yung negative 2, di ba, yun ang una niya, tapos yung pupunta siya sa 0, di ba? Kumbaga, you start with the higher value. What is the higher value? 0 or negative 2? 0, kasi mas mainit eh. 0 minus, dahil delta nga, di ba? Higher minus lower, because we don't have negative. If we have negative, ibig sabihin, change lang yon, change lang ng direction, no? Either given off or absorb, release or absorb yung heat. So 0 minus 2. Minus means delta, no? Minus higher temperature minus the lower. Lower is negative 2. Magiging negative is what? Magiging positive, no? Kaya magiging positive to yan. Ngayon, punta na tayo. We go to the LF. Do we have LF? May latent, no? Kasi natunaw nga yung yellow eh. Pag natutunaw yung yellow, meron tayo yung heat of fusion. How much that? I think 334 or 335. No, wala namang problema diyan. 334, 335. Ngayon, eto, no, kasi constant yung mass, ibig sabihin distributive yan, no? Mass dito, tapos mass i-multiply mo rin dito, no? Ngayon, alam ba, do we know the CP of water? Do we know the CP of water?
Yes, sir.
4.187. Diba? Kilojoule per kilogram Kelvin. Do you know the delta T involved in the water? Alam ba yung mangyayari sa tubig? Ano? Yung tubig, di ba yung yellow naging tubig, anong target natin?
5.
5. Kasi tubig na yan eh. Kung 0 lang siya, tingnan nyo kung di ba yung negative 2 naging negative 1, kung 0 lang siya, kung 0 lang siya, di ba, yellow pa yan, tas naging tubig, di ba? Kaya nga nagkaroon ng latent heat of fusion. Ito 'yon, no? Nung tubig na siya, 5, no? Mas mataas siya dun sa pinanggalingan niya. Ano 'yon? Ano yung ito yung higher temperature 5. Ano yung pinanggalingan ng tubig?
0.
Zero, 'di ba? Zero, yung zerong ice naging tubig, 'di ba? Kahit na plus 'yan or minus, minus zero, zero pa rin 'yan, no? So 5, no? So considering this, lahat pag pinlog in mo 'yan, meron kang mass ng apple which is 1 ano to? Ay, ilan to? 1,000 kilogram, meron kang CP, 'di ba, ng apple, ano 'yon? 316 ba 'yon?
3.64.
3.64 po.
3.64 tapos delta T ng apple, yung na-involve sa apple ay 0 minus 2. So meron kang 2 rito. Ito 3.64, pina-plug in ko lang na para malinaw. Ngayon, CP ng ice, alam ba yung CP ng ice, class? Ano 'yon?
2.108.
2.108. Yung delta T ng ice. Ano ba yung mga delta T? Ano ba yung temperature na na-involve yung ice? Mula sa kanyang zero, ano ba 'to? Yung 2, no? Yung negative 2 na ice, 'di ba? Naging 0. So dito ka sa higher temperature, 0 minus 2. So plus 2 na 'yan. Ano yung latent heat of ice? 334 or 335, no? Walang problema diyan. Ngayon, eto. CP of water, alam ba?
Opo.
4.187. Ano naman yung mga temperatures? What are the temperatures involved in the change of temperature in water? So,
5 to 0.
yung 5 kasi
0.
yun yung target natin na mainit. Galing siya sa 0, 'di ba? So minus 0, wala namang minus 0, 'di ba? 0 na nga origin yun eh. So wala 'yon. 5 0. So 5 'yan, no? Pag kinompute mo 'yan, eto na, no? Na-plug in ko na lahat. Ulitin ko lang sa kaalaman ng lahat, no? For the benefit of everyone. What is 1,000 kilogram? Yun yung mass ng apple. 3.64 specific heat of apple. Ito, delta T na nangyari sa apple. Ano naman yung 2.108? Specific heat ng ice. Ito naman, ano to? 0 minus 2, no? 0 minus 2 is yung delta T na nangyari sa ice, 'di ba? From negative 2 naging 0, tapos naging tubig. Nung naging tubig na siya, class, nag-release siya ng energy. Anong tawag doon? Latent heat of fusion, no? 334 or 335. Ngayon, ito naman, ang involved dito ay yung CP delta T ng water. No, CP is 4.186 at ito naman ay delta T na na-involve ang tubig kasi yung yellow mo na negative 2 dapat makarating siya sa 5 at yung lower naman na pinanggalingan niya ay 0 degrees na water because yellow nga dati naging tubig, no? So 0 minus 0 ay 5 minus 0 is 5 lang, no? So pag kinompute natin, if you're going to calculate this, magkakaroon tayo, we can arrive at this, no? So it's a lot longer here, but I might simplify 2.2.97. Sabi natin 220 3, okay lang? I-compare natin. 223 is the amount of ice needed. Available is what? 100 kilogram. Anong decision natin? What is our decision? Is 100 kilogram enough or not?
No.
What's the decision? 100 kilogram is not enough. Okay? Tama ba? 100 kilogram of ice is not enough to cool what? The apple, which is 1,000 from 27 to 5. Sabi, will not suffice, no? Will not suffice. So, hindi. Okay? Maliwanag ba, class? Is it clear?
Yes, sir.
Ngayon, mabilis lang to. Ito naman, next, mabilis lang. No, we're going to make it fast, like mga 2 minutes, no? So now we are going to consider another problem, which is this. Now, how much time in hours will it take to cool 5 metric tons of water from 27, which is like a ambient temperature, to -5 using 20 kilowatts cooler with 90% efficiency. So what makes it more complicated this time is this 90% efficiency. Okay? May efficiency yung ating system, meaning it's not perfect efficiency because perfect is 100%. Kung anong binigay mo, whatever energy you put, that's the energy you get. So it's not like that because efficiency is what? Always output over input. Okay? So output over input, laging ganyan, no? So kung anong resulta, di-divide mo sa input mo, sa binigay mo, dapat mataas siya, no? Ngayon, the problem states that our system is only 90% efficiency. What is inefficiency? What is another 10? Yun yung inefficiency niya, no? Yung parang error niya, no? Inefficient. Ibig sabihin, that's the in a common term, anong tawag dito? Loss, energy loss, no? So, siyempre, may loss due to heat, loss due to mga bending ng mga tubes sa refrigerant, loss sa mga energy, environment. Okay? So, let us now go to the given. Ano yung given? Power. What is our power? Power input. What is the input class?
20 kilowatt.
20 kilowatts. So, as I told you, efficiency, now the other here, the other configuration of efficiency is this, no? Greek letter, eta is power output over power input, no? Ngayon, this is the power, yeah? So, power output, if you want to get the power output, what is that? Efficiency times the power input. Basically, our efficiency is 90%. When you are going to put that in the calculation, you should convert that into decimal, right? 0.9 times what?
20.
20 kilowatt. Ibig sabihin, hindi talaga 20 kilowatt ang naita-transfer niya kasi nga may 90% na efficiency. It's less than the ano no, yung output natin is na-absorb ay less than na ng 20 kilowatt. Ngayon, eto, punta natin to. What is 5 metric ton? Basically, it's only 5,000 kilogram of water. Okay? Maliwanag yan. Ano yung 27 tsaka -5? Ano to? Ano to? What is this?
Eh?
Temperature initial of water is 27. Then, temperature final, no, of water, which is naging ice na nga, no? Final temperature of water na basically naging ice is -5. Okay? So, we go immediately to the calculation. Basically, what we're trying to find out here is the time required to make, no, the ice making of water, which is 5,000 kilogram from an initial temperature of 27 degrees centigrade to -5. Now, so we go to the solution. We are having this data. Some of these are not given in the problem, but they can be searched. They are known to us. They are constant. No? Specific of water is 4.186. Specific heat of ice is 2.108. The initial temperature of water is 27 degrees centigrade. We know, everyone knows that the freezing point of ice, when the water reaches 0 degrees centigrade, it will become ice, right? The freezing point of ice is 0 degrees centigrade. What about this? -5. That is the target, no? The target temperature for the ice from water, which is 27, to the ice, which is -5. No? What is the 5,000 kilogram? The mass of the water that we're going to convert into ice. What is this? Latent. It is going to be involved because there's a change in phase, no? From water to ice, so we will be using latent. What is latent? Latent means hidden or concealed, no? Nakatago. Hindi mo siya ma-feel, ba't hindi mo siya ma-feel? Kasi ang nafe-feel mo ay sensible heat. Yun yung heat na may measure ng temperature. Mame-measure mo ba yung latent? Hindi. Kasi hindi naman siya nagbago ng temperature. There's no heat transfer. Yung 0 degrees centigrade na tubig, naging 0 degrees na ice. Wala namang pinagbago sa temperature. There's no change in temperature. You cannot measure the temperature, but you can see the something has happened. Something has changed, like the form or phase, no? Yung tubig naging yellow. So, merong energy na involved doon. And that energy is called latent heat, no, of fusion, LF, which is constant, not 334 or 335. Now, I just explained earlier, no? So, efficiency is always power output over power input. If you want to get the power output, the actual is, you should multiply the efficiency times the input, right? So, input is what? What is the input? 20
20
kilowatt.
kilowatt.
And there we have 90% efficiency. If we're going to put that in calculation, so we should convert that into decimal point, which is 0.9. Now, the other one, the last one is -5, which is the target temperature for the ice. Kasi, di ba, 0 is the freezing, then below, naging -5. It becomes -5, okay? So now we go to the solution. Still, energy in, energy out is first law of thermodynamics. Yeah, right. And the second law also applies because the heat of the water is being released, right? The heat of the water is being released papunta doon, no? Na absorb at na para maging yellow. Dapat alisin mo yung init. You should take out all the heat from the water para maging yellow. You should transfer the heat because water has heat. I should take it away. Alisin ko 'yon, i-transfer, alisin ko 'yon para maging malamig at maging yellow, no? So ito na yung formula kanina, sinulat ko already. I have written this for many times, several times. PI is the input, 20 kilowatts, efficiency is 0.9. We have 18 kilowatts, which is coming from 20 kilowatts na output naging 18, no? Meron tayong loss. Ilan yung loss? How many are loss? Loss.
2 kilowatt.
2
2
kilowatts.
kilowatts. We lost 2 kilowatts due to heat and due to other, reasons. Now, the energy of water is equal to heat of water, latent, no? Latent to. Kasi yung water naging ice, so, which involves latent energy, latent heat, no? Then, sa ice form na, no? So, all these are based on the general formula, which is MCP delta T, right? Mass flow times specific heat times the change in temperature, which is the universal heat formula for heat transfer, thermodynamics, and power plant, right? Now, here, we go to this, now, power output, which is, I think we were given this, now, 18, 18 kilowatts, and now we were given the time, 18 kilowatts times time, no? Naintindihan nyo ba? Do you understand that equation? What is power? Power is work over time, right? Ibig sabihin, kilojoule per second. If I want to get the time, no? So, pwede mo siyang work over power, no? But in this case, dahil kinuha na natin yung equation, so pwede na nating gawing ganito, no, sa heat, no, which is W, no? Because work is energy, no? Energy is ability to do work, and work is here. So, what is work now? Work is power times time, right? Anong power ang pinag-uusapan natin? What power are we going to talk about? We are going to deal with here? Output, because that's the actual power being impart. No? So if we are going to multiply power times time, no, magiging work 'yon, di ba? Magiging work. So here, ito ay basically work. Work is energy and heat is energy, no? Heat is a form of energy. That's why meron tayong energy dyan, which is, 18 kilowatts, no? Kasi output na nga eh. Output ang pinag-uusapan natin, no? 18 kilowatts, no? Maliwanag yung equation? Kung saan nanggaling yan, no? Rearranging the equation, so we will have this mass of water, Cp of water, delta T of water. Then we have this latent heat of fusion because from water naging ice, so it involves latent, means concealed energy or hidden, no? There's no change in temperature, but there's a change in phase. Then what is this? So this, no, naka-distributive naman yan. You have to multiply the mass of water times this, mass of water times this. Ito naman ay involvement ng water, no? So pag nilagay natin 'yan, here is the mass of the water. This is the specific heat of water. This is the delta T change in temperature of water from 27 magiging 0 muna siya bago siya mag-yellow. Okay? 27 to the 0. No, pag 0 na naman magiging papunta na siyang ice. 0 ano to? Water papunta, going to zero ice. Anong nangyari doon? Ito, latent heat of fusion. May involvement na energy. Latent heat is 334 kilojoule per kilogram. So, we're very clear on that. Now, this one here is about water. Why? Because I mean, about ice, no? Water na naging ice. This is purely water. This one here is purely water, right? So this one here is purely water. This one here is purely ice. So our ice, the specific heat of ice is 2.108. Now, the delta T here is what? About the ice, no? Our ice has a higher temperature which is 0 degrees centigrade because uh, tapos na. Ay, class, natapos na tayo, no? So, class, hello, natapos na tayo, no? Nakat na yata, no? Na time na. Pero patapos na tayo, 'di ba? Pag inano niyo lang, pag tinuloy mo 'to, 'di ba? Pag tinuloy mo 'to, ito yung involvement sa ice, 'di ba? Yun lang ang pinag-uusapan natin. Uy, ito lang yung pinag-uusapan natin dito. Ito yung involvement natin sa ice, no? So pag pinlog in mo, tatapusin ko lang, no? Pag pinlog in mo 'yan, pinlog in mo, mapupunta ka na doon sa ice, which is 0, yung higher niya, papunta sa negative 5. Minus 5 is plus 5, no? Pag kinumpute mo yan, 35 hours. Ilan ba yung 35 hours, class? Ilan? Ilang araw tong 35?
Isa't kalahati.
Isa't kalahating araw because 24 hours, no, pag inano mo to, 35, no, divided by 24, you will get 1.4 something, no? So 1.5 hours. So kailangan natin, we need 1.5 hours to convert an amount of 5,000 kilogram of water from 27 degrees to negative 5 na ice. Maliwanag ba? Okay ba 'yon? Class, maliwanag ba 'yon?
Yes, sir.
Okay. So hanggang dun muna tayo and then later on pupunta na tayo sa sa application na standard vapor compression tsaka mga refrigerant. So maraming salamat and have a good day, okay? Thank you very much.